Thank you. Welcome. Welcome. Then, uh, respected sir and my friend, my presentation is hyperboloid and minimal surface. First of all, hyperboloid. Hyperboloid is the open surface generated by revolving hyperbola about either of its axes. If the transverse axis of the surface lies along the x-axis and its center lies at the origin, and if a comma b and c are the principal semi-axis, then general equation of the surface is expressed as x square by y a square plus minus y square by b square minus z square by c square is equal to 1. Now x square by a square plus y square by b square minus z square by c square is equal to 1. X square by square minus y square by b square minus z square by c square is equal to minus 1. This is the equation of hyperboloid. And then continue the what is hyperboloid. The revolution of the hyperbola about its conjugate axis generated a surface of one sheet and hourglass like a shape. You can see in figure below, for which the second term of above equation is positive. The intersection of the surface with plane parallel to xz and yz plane are hyperbolas. Intersection with planes parallel to xy plane are circle or ellipse. Hyperboloid or hyperboloid, a quadratic surface whose section by plane parallel to one coordinate plane are ellipse, while those section by plane parallel to other two hyperboloids if proper orientation of the axis is assumed. Mainly there are two kinds of hyperboloids. In the first case, plus 1 in the right hand side of the equation. One, one has one set hyperboloid, also called hyperbolic hyperboloid. It is connected surface which has negative Gaussian curvature at every point. Negative Gaussian curvature at every point in one set hyperboloid. This implies that tangent plane at any point intersect at hyperboloid at two lines, and those that the one set hyperboloid is doubly ruled surface. In the second case, minus 1 in the right side of the equation, one has the two sets hyperboloid, also called elliptical hyperboloid. The surface has two connected components and a positive Gaussian curvature at every point. Those surface is convex in the sense that tangent plane at every point intersect the surface only at this point. Here is a figure. The one sheet hyperboloid, two sheet hyperboloid. In figure we are clear. And hyperboloid of one sheet and two sheet here also. It's another figure. First figure one sheet, second figure two sheet. Then hyperboloid of one sheet, generation by rotating hyperbola top and line bottom red or blue, that is a hyperbola. How to construction of hyperbola in one sheet. Hyperbola of two sheet, generation by rotating a hyperbola, that is two sheet here. Then in figure here also, in hyperbola in the curvature is negative, then you can see the figure here. This next one, that is a minimal surface. What is a minimal surface? Let S R vector is equal to R vector U B be a surface. There is one surface. Now S is called minimal surface. S is a minimal if mean curvature of this surface is 0. If mean curvature of this surface is 0, then surface is minimal. This surface has kappa A plus kappa B at all points. Those the necessary and sufficient condition for the surface R vector equal to R vector U V to be a minimal is kappa A plus kappa B is equal to 0, or En minus 2Fm plus Lg upon Eg minus F2 is equal to 0. Then En plus Lg minus 2Fm is equal to 0. Then one minimal surface, the curvature along the principal curvature planes are equal and opposite at every point. This makes the mean curvature 0. Planes of principal curvature, normal vector and tangent plane we see in figure here. Now, now I'm clarify about examples of minimal surface. Then example of minimal surface. Then I take the one example, that is uh, fx fxyz is equal to x comma y log cos y minus log cos x. We take this surface, then so that this surface is minimal in Mathematica, and clearly here, then shift 1 r1 with respect to x, r2 with respect to y, r11 with respect to this x, this, 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 then h, value of h, then value of a, then value of m, this value of m is equal to 0, value of n, then now this u is equal to 0, then u is equal to 0, the value of mu is equal to 0, then the mu is equal to 0, then mean curvature is 0. Mu means mean curvature. Mean curvature means en minus 2 fm upon lg upon h square, that is mean curvature. Mu is equal to 0, the surface is minimal. Then now we are plotting that surface. The surface, we plot that surface, then the surface is moving. There is dance, surface is dance there. Okay, this surface is dancing. There is a minimal surface here. The there is surface, one surface, two more surface there. Okay, thank you. This is my presentation. Thank you, my sir and my friend. Okay.